So today's lesson is going to be in your Unit 3 note packet. It's day 3 called Function Notation. So a function is a rule that takes an input, usually we use x, does something to it, and gives a corresponding output, which we usually use y. So there's a special notation that we're going to use called function notation. That is used to represent the situation. So this next part here is just going to give you an example of what the variables will look like. So if the function name is f, for example, and the input name is x, then the unique corresponding output is called f of x. So that is how we read this out loud. We say f of x, and that's the output. So basically, this notation, f of x, is the new way that we will write our y's, or outputs. So if you think of f of x as y as we move forward, we will be able to do this. So it says we can evaluate functions from a given table, a graph, or a rule. So example 1 we're going to start with is a table. So two functions are shown in the table. We have f of x here, and we have g of x over here. See if I can bend that pen a little bit for you. See if it saves. Not sure if it'll save if I go back, but that's okay. So the first question says we want to find f of 1. So f of 1 means our x value is 1, and it wants to know what is the output for the f function when the input is 1. So we're going to come over to our table, and we're going to look down the column where the x's are, and we're going to find that 1. So here it is. And this point that we're looking at is we need the y value that goes with this 1 when we're in the f of x column. So that answer is -4. Again, it's basically asking what is the output for y when x equals 1. That's what you're asking yourself. Okay? So the next one is g of 2. Let me switch over to the screen. Oh, it did say it. Excellent. So g of 2. So this is telling me that my input, or my x value, is 2. Whoops. And I want the output. So I go over to my table. I find where x is 2. I need my g output. So I'm going to come across over to the g, and the output is -6. All right, we got one more. Let me erase a couple of these lines so we don't get all mixed up. All right. So this next one wants f of 0 plus g of -2. So f of 0, I'll use my purple for my f function. So f of 0, I'm going to come over to where the x is 0, and I'm going to look in the f column, and I see -1. Then I need my g. Turn over to my green, g of -2. I'm going to go to my -2, and I want the g, which I see is 0. And then I'm simply going to add them together. And so my answer is negative 1. All right, so that is function notation from a table. The next one we're going to look at is function notation from a graph. So I'm going to do the same idea with these colors to kind of help you. So the two functions again are f and g. They're different. They're not what was in the table above. And this is my f function. So I'm going to trace him over. You can feel free to grab a different color pen if you'd like to do that as well. And then I'm going to use my pen again here for my g of f. So you got to read the labels. That's how I know which one's which. All right. So the first one is g of negative 2. So what? No, that was supposed to be green. Let's see here. Undo that. That green. There we go. G of negative 2. All right. So I need to find the output, or y, when x equals negative 2 on the green line. So I'm going to come over to where x is negative 2. So here's the origin, here's negative 1, here's negative 2. Then I'm going to move up and down this vertical line until I get to the green graph. So this is the point on the G graph where x is negative 2. So then I need to read its y value. So I look across and the answer is 1. Basically, you're looking for the end of the coordinate point. Negative 2, comma 1 is the point that goes together. All right, now we'll try this f of 2. So I'll get my purple. I need to find my y value when x is 2, and I got to be on the purple graph. So I'm going to go over to where x is 2. So here's the origin, here's 1, here's 2. Then I'm going to go until up and down the vertical line of 2 until I touch the pink graph. Well, hey, I was right on the graph. So this is the point right here. So then you ask yourself, what's the y value? And your answer is 0. All right, let's try one more. Let me give you a second to think about it while I do some erasing up here to make this a little less messy. So take a look at that question and see if you can figure out those two separate parts. Graph. All right, so the first one is f of 1. So when x equals 1 on the purplish graph. So here's x equals 1. I go down until I hit the graph, down or up. In this case, it's down. And then I read across, and I get negative 1. Then I need g of 2. So I'm going to go over to x equals 2, which is here, and go until I hit the green graph. And I'm going to read across. And I know the lines are a little blurry. So you can count from here. 1, 2, that must be a 3. And then there's a plus sign in between. So negative 1 plus 3. And my final answer is 2. So here are your final answers. A function notation from a graph. All right. So the last part is where it gets a little more involved. How does this work when given a function rule, otherwise known as an equation? So for example, the function rule, highlight this area. The function rule y equals 3x plus 4. If you want to write it in function notation, you simply take the y out and replace it with So y equals 3x plus 4 is the same as f of x equals 3x plus 4. It says, but what does that mean? So the function rule f takes x, the input, and what does it do to it? So if you look at the equation, the x is located here, which means you're going to take the x, multiply it by 3, and then add 4. So it multiplies it by 3, and then adds 4. The result is your output, f of x. So for example, let's say x equals 3. I put it into my function rule. My function rule says 3 times your x, so 3 times 3, and then plus 4. It goes through the machine, they do the computation, 3 times 3 is 9, 9 plus 4 is 13, and that's what pops out. That final answer is 13. All right, so then it says each point we typically call x and y can now be called x, comma, f of x. Again, just reiterating that f of x is our new y notation. All right, let's see what we got here. So this one, our first rule is here, f of x equals negative x minus 15. And the first question wants f of 4. So I'm going to grab my pen here, and I'm going to do what I've been doing on all the other ones. That means the input, or the x value, is 4. So if I want f of 4, I take this, I go over to the function rule, and I fill it in for x. Technically, you would fill it in here as well, but that's already given, so you don't have to rewrite it. So f of 4 equals, there's a negative. You know my rule about parentheses. Whenever you are inputting a number, you're going to use a parenthesis, and then minus 15. From there, all of these problems can be calculated with your calculator if needed, or you can try to do them in your head. But please use your calculator to check, especially when the equation gets a little bit more complicated. So negative of 4 is just negative 4, minus 15 is negative 19. So if I was to graph this function rule, which we will eventually do, there is a point at 4, comma, negative 19. The point is not your answer. The answer is just negative 19, but I just wanted to show you that that's what the point would be. All right, f of negative 10, same idea. So I take this negative 10, get rid of some of these arrows, and switch up our color a little. We're going to take this guy, and we're going to put him in there. So it's going to be negative. Then your number, negative 10 minus 15. Oh, be careful of those double negatives. There's a negative in the rule, and then your number is negative that you're filling in. So when you negate a negative, that turns to positive 10. And then again, you can use your calculator. You could type in the original or this 10 minus 15. Both are fine. Oops, that looks a little too messy. There we go. So the answer is negative 5. All right, one more. Let's do f of 0. So this means x equals 0. So I take the 0. I put it into the equation. I get negative, parentheses, 0 minus 15. Negative 0, well, that's just 0. 0 is not positive or negative, right? And then minus 15. The answer is negative 15. So again, you can do them in your head like I did, or don't be afraid to just put this all into the calculator. Your calculator knows how to handle the parentheses and the PEMDAS, so you can use it if you'd like. All right, let's see what example 4 says. Example 4 says, for g of x equal to x squared plus 2x minus 1, find the range given the domain negative 4, 0, 8. So from day 1's lesson, we talked a lot about domain and range, and day 2. And on day 1, we identified the domain as the set of all input, or x's. So these are 3 different x's that we want to fill into the equation and find the y values for the range. All right, so here's my equation. I got to do 3 different numbers. I need g of negative 4. I need g of 0. And I need g of 8. Now you are going to show your work when you do this, right? So you're going to show me the filling in of the number. Oh, this is where those parentheses become so important. That negative 4 in parentheses squared on the outside plus 2, fill in the negative 4 again, minus 1. What did I just do? Took this negative 4, put it in here and here. There's 2 x's in the equation. It goes into both spots. So then again, you can put it in your calculator or you can do it piece by piece, whichever you're comfortable with. So that would be, let's see, 16 minus 8 is 8 minus 1, which is 7. Oh, I don't really need to box it. It's not my final answer. All right, the next one is g of 0. So in those same 2 spots, I got to fill in 0. So 0 squared, always in parentheses to be safe, times 2 times 0, minus 1. That's an easy one, right? 0 squared is 0. 2 times 0 is 0. Minus 1, get negative 1. And the last one, we're going to fill in 8. So 8 squared plus 2 times 8 minus 1. So let's see, this is 64 minus 16, which is 48, right? Minus 1, so 47. I'm sure someone will correct me if that's not right. All right, how are we going to write our final answer? Well, they wanted the range, right? So we're going to do r colon, our curly bracket, y, such that, and then list them. You don't have to put them in order from smallest to biggest to get full credit, but that is how I generally like to see it. And there you go. All right, let's see about the last one. Oh, it's not the last one. There's a couple more. All right, the next one says, example 5. Oh, this is where the twist is. F of x equals negative 8x plus 27. So that's your function rule. And this time, we want to find x when we know f of x equals negative 13. So we have been saying over and over again that the number they're giving you is the x. But now, it's the y, or the output. Oh, my board is mad at me. So we're going to take this negative 13. We're going to make it the output. So negative 13 equals negative 8x plus 27. So let's put a little star by this one to be careful. So we will throw in a couple where you're not filling in for x, and instead you're filling in for f of x, which is the answer. So then we got to solve for x. Well, we know how to do that. We're going to use the subtraction property of equality and subtract 27 from both sides and get negative 40. And then we're going to use the division property of equality divide both sides by -8. We're going to find that x equals 5. Sorry for that crazy 5. All right, last question. We have f of x equals x plus 2 and h of x equals -9x squared plus 6x. So we have two rules. So I'm going to use two different colors. Try to help you keep it all organized. I'll use green for my h. All right, let's see what we can do. The first one is f of 1. So I'm going to go to purple. I'm going to go to my f rule. I'm going to fill a 1 in there. So it's 1 plus 2. That's easy. That's just 3. I'm going to fill in my 3 into both. Into my h rule. Oh, there's two x's, so be careful. Got to go on both sides. So that one's going to be -9, parentheses, 3 squared plus 6, parentheses, 9. Oh, sorry about that. That should be a 3, right? That's my x value or my input. All right. Again, I would put this all right in my calculator if I were you. If you want to do it by hand, piece by piece, you have to follow PEMDAS. Exponent first, that's 9. 9 times -9 is -81. 6 times 3 is 18. We would subtract those. We would add them, sorry. Technically it's subtraction. And we should get -63. All right, so I have my f of 1. My f of 1 is 3. I have my h of 3 is -63. The original problem wanted me to add these. So it's 3 plus -63, which equals -60. Whoa! All right, are you ready for the last question? I bet you are. So the last question, what in the world? A diamond is going into the f equation. So don't worry about this 2. We'll handle that at the end. So f of diamond is diamond plus 2. Really? That's what it is. I'll color it in, make it look the same. All right. We know what this means. 2 with a dot means 2 times that. So we're going to distribute and get 2 diamond plus 4. Yeah, I know that's silly, but that's your answer. You just leave it with that diamond. All right, from here, I'd like you to open your homework packet, leave your notes out to help assist you, and I'd like you to complete the page of homework day 3 that is in your packet. All right, thanks guys, have a great day.